Hello, and welcome to the third normal form. Now we got through the first normal form, and now we got through the second normal form. We're basically at the final rule. We mentioned in the original video about normalization that there's actually 5 rules. However, most people only apply to 3. I'm not even quite sure what the fourth and the fifth are. You can look those up, but you'll never really apply them. Even when it comes to the third rule, it's going to be very rare that you'll actually apply this one. With that said, though, it's important that we actually look at it and make sure you understand it so when the situation does occur, you can take care of it accordingly. All right? So we're going to do the same thing we kind of did in the previous videos. We're going to talk about what the third normal form is. We're going to talk about how you recognize that a table is not in third normal form. We're going to figure out what the third normal form accomplishes. We're going to apply the rule, and once again, we'll show you by example how to do so. Okay? Normal form is very easy to recognize and apply. I guess I could say that. So it simply states eliminate data not dependent on the primary key, or if the attributes do not contribute to the description of the key, remove them in a separate table. Those are kind of what do you want to say? Not straightforward definitions. They are once you get used to it, but when first looking at it, I can only imagine that you're probably saying, what does that mean, not dependent upon the primary key? So basically what we're saying is this, that if your entity holds a piece of data, a column, that truly doesn't define that entity, okay? Meaning it's not, it's, it doesn't define that person, that student, that instructor, that whatever it is we're looking at. Maybe it defines multiple ones. Regardless, it should come out and be its own table. The rules around normalization was always one of scalability, efficiency, but also definition. One that said that everything within a table should be basically defining that particular table or that particular entity. So that's what that means by the primary key representing that instance. Does that make sense? Once again, very rarely you're going to see this actually out there, okay? And if you don't handle third normal form, I'm not sure there's really overly a major, we want to say, negative to not handling third normal form. But the whole idea of third normal form is just that, to ensure that every column now within an entity truly represents that entity. All right? So what does it accomplish? It's the same thing as second normal form. Avoid updates and delete anomalies, organization and simplicity, and basically defines your database just a little bit better. So it's a good idea to store entity details for just one entity per table. That's kind of the whole idea, meaning the details of an entity are truly the details of the entity. There's nothing more in there. How do you recognize it? Well, because we applied first normal form, we know there's no repeating columns or group. Because we applied second normal form, we've handled all the redundant data. So the only entity columns that should be left are the columns that do not repeat and aren't used more than once. This means we won't have to apply third normal form very often. Matter of fact, I had a hard time even coming up with an example for you. Okay, so they're not very common. So, once again, I wouldn't really stress over third normal form. Understand it, but don't stress over it. However, if after analyzing each table, you find a column that does not contribute to the description of the primary key, then it should be removed. How do we apply it? We analyze each table to determine if every column is functionally dependent on the primary key, meaning the column does not contribute to the description of the primary key or what the primary key represents. Then it should be removed. Okay? How are we going to do this? Basically, it's the exact same rules as second normal form. We're going to create a new table. We're going to create a unique primary key for that new table. That new table will become the parent table. The originating table is now the child table that we hold in the primary key, the foreign key, I should say. We're going to move all the attributes representing the redundant data, but we're going to move all the attributes to the new table, and we're going to delete all moved attributes from the child table to replacing it with the foreign key. Okay, the exact same rules as second normal form. All right. So my best example I could come up with when I actually looked at this, if you actually look at this data, was this thing called high school. All right. So we had high school and high school location. As you see, it was not redundant. Now, it's possible it could be redundant, and so second normal form very easily could have handled this. But for sake of example, in our example here, they were not redundant. So if we actually looked at our data, we saw that it really wasn't redundant. But does high school truly represent or define the students? Okay, and so in this case here, well, no, because a lot of kids go to these high schools. Just because it wasn't redundant in our database, a lot of kids go to these high schools. So with that said, it's not functionally dependent upon the primary key like name and so on are. Does that make sense? I hope so. I know this is a tricky one. Excuse me, but once again, it's not something you're going to do very often, okay? But that's what we're trying to say here. Fields or columns that we find that could be represented, it doesn't really functionally to represent the students because others could have gone to this high school, all right? So if we find something like this, the whole idea is to, once again, break it out. So very simply, following the rules, we come here and we would say high school. Okay, we would give it a high school ID. And in this case, we would put high school. And we would also put high school location. So we would move these fields down to here. This becomes the parent table. All right. And just like this, it's almost like a one-to-one relationship in this case because we're saying it doesn't repeat. But in this case, we'll make it a one-to-many just in case it ever does. Okay. So if this is the case here, and since this is going to hold the foreign key, this will be the high school. Whoops, sorry about that. There, okay. A little bit too far. We'll fix that up. Let's come here, and this is going to be the high school ID. We are going to delete this one, and finally, we'll make this the foreign key. And thus, we're in third normal form. Now, if any time all of a sudden this repeats, it's handling it. So it's almost like second normal form. So once again, the third normal form is this oddity that's kind of out there. It's just catching things that, it doesn't repeat, but doesn't really define the entity itself. And if that's the case, it should come out. Does that make sense? Don't make it any harder than it is. It's actually pretty darn simple. But you're not going to find these very often. Very, very rare. All right, so don't worry about them too much. And now when we look at our table, okay, I'm going to kind of bring this out a little bit, or I should say our table, our database, we see what we've done to the good old student course database, where we had student courses and instructors at one point in time, okay? So in this case here, you see that things have really grown, and they've grown exponentially, especially with second normal form. So that's what's going to happen to your databases as you kind of get into them. You're going to see these things kind of grow and grow and grow because second normal form is going to really kind of make sure we don't have that redundant data all the way through it. So when we first started this, we had 1, 2, 3 tables. We added our many, many tables, and now look what we're up to. 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, by now, you should understand that what we're doing here is storing data efficiently, accurately, scalably, if that's a term. I don't think it is. We're going to make it scalable, I should say. Okay? And that's what we accomplished. And now you also know that this is just storing of data. So by storing this data efficiently, we can now get it out very, very quickly. And by getting it out, we use our select statements and our join statements in which you've already been introduced. And we'll keep practicing those throughout the rest of the course. Anyway, there you go. First, second, third normal form. Let's have some fun trying to learn these things and applying it to your own databases.